So I am going to explain 3D design of a propeller hub assembly. It contains two blades, then barrel, then orange color barrel with the two halves, front and back, then spinner, fore and after body. Fore body is like a dome, after body is like a plate. So we are going to make each component separately, then we are going to assemble it together as a propeller hub assembly. So I am going to start with this propeller blade. So here I have mentioned the dimensions. Propeller span of 1000 mm. So here it is circular, then it is airfoil shape of different angle of attack. So the same span wise position here I have shown. So along the span we have around 5 planes. So this is the root section, left hand side, right hand side tip section. So along that 5 planes we have different cross sectional profiles. Near the root 2 circles, then after that we have 3 airfoils with different chord length and angle of attack. You can see angle of attack is reducing from 35 to 0 like a washout wing. So I am going to start with this third plane where I have the airfoil profile of 100 mm. I am taking NACA 242 airfoil for all the planes. So I am going to start with this third plane. Then I am going to design offset another 2 planes in the left hand side, another 2 planes on the right hand side, then remaining profiles. I am going to proceed. So this is the final assembled product. You can use the explode view. So 2 blades, barrel of front and back half, then spinner body, fore body and after body. Everything we are going to assemble it together. So I am going to start with this propeller blade. So straight away I am taking the NACA 2412 airfoil at 100 mm chord. So you can see my previous videos for how to import the coordinate point from Excel to Catia. So same procedure. So this is the third plane. Now I have to create other 2 planes on the left hand side to create the circles, then remaining 2 planes on the right hand side to create the airfoils. So to offset the plane in the reference plane, the plane tool you have to use. So here you see this plane is at 100 mm, then the second plane is at 150 mm. So first 100 mm, reverse direction, then from here another 150 mm. So this side you have created 2 planes. We can create the circle also now itself. So circle of dia of 50 mm. So I created 2 circles. Now we can offset the plane on the right hand side to create the airfoils. So the distance is totally 450 and 1000, but if you take it from this third plane, it will be 300 and 850. So first plane is at 300 mm, and the second plane is at 850 mm. So now we have to create the airfoil, that is we are going to copy paste this airfoil here, then we can change the chord length and angle of attack. So copy the airfoil profile, and while pasting, instead of pasting in this plane, you do all those operations in the tree itself. So here you paste the profiles. Now we got 3 airfoil. So then we will change the airfoil chord and angle of attack. First I am taking first sketch. So chord length is correct, it is 100 mm. So chord length is 100 mm, angle of attack is 35 degree. So we have to rotate this airfoil at 35 degree. So in the operation toolbar, 4th one rotate tool we can use about the center point. I don't want the duplicate, I need only the modified one. And then angle is 35. For clockwise you have to give minus value, minus 35. So now the aerofoil is at 35 degree. Then second aerofoil, so here the chord length is 120 mm, angle of attack is 15 degree. So we have to increase the size to 20%. The same operation toolbar, use the scale tool about the center point. I don't want the duplicate mode. So scale is increased, then angle of attack here is 15 degree. So again minus 15 degree. So angle of attack is changed. Then third airfoil, it is at 0 degree only. Simply chord we have to change it. So chord is just 50 mm. That is 50% we have to reduce. So about the center point, the scale is reduced to 50%. So now we have the required cross-sectional profiles. So finally we are going to make a solid part. Straight away you can try the multi-section solid to create all these aerofoils and these two circles, but as the angle of attack is more, then there is a transition from aerofoil to circle. You may not get the complete blade profile properly. So instead of going for the multi-section solid, first I am going to create the surfaces. There are two separate surfaces, upper surface and lower surface. So to create the two surfaces, I need two separate profiles. Now this is as a single profile, aerofoil as a single profile, but I have to divide this into two profiles, upper surface, lower surface. So all those divisions, surface creation and all, we have to do it in wireframe and surface design. Go to wireframe and surface design. So this toolbar, operation toolbar, the first two tool if we expand, there is a joint, also there is a disassemble. So using this disassemble, I can divide all those profile into two halves. That is, with respect to this points, it will be separated. So now we can give OK. Now you see lower surface, upper surface, it is divided. Now using multi-section surface, we can create the surface first for the upper surface. So I am selecting all the upper surface profiles. Preview, so it is coming properly. Then we can create the lower surface profile using multi-section surface. Same tool. Select the all lower surface profiles. Preview. So now we have created the blade profile using two surfaces, and we have opening on both ends. That also we have to fill. So this side it will be flat. So straight away I can use the fill tool. I can get the flat circular sheet. And another side, this corner, if you want, you can fill it as a flat surface, or you can give the curved surface. So if you want to try the curved surface, then you can use the blend. So in the blend tool, you have to first select the curve, then the supporting surface. So this is my first curve, then this is the supporting surface, then this is the second curve, and the bottom is the supporting surface. Now give OK. You can see there is a blend fill is generated. That's it. We have created the complete surface model. The jointing has to be done in the wireframe and surface design. So the same tool. So here we have disassemble. The first one is the joint. So we are going to join all four surfaces. Okay, to upper lower surface, circular edge and tip edge. So now you joined. Now there won't be any gap, and this will be a single closed surface profile. Now we can convert this into a solid using this thick closed surface. select. Now we have converted surface into a solid. If you want to visualize, we have to hide these 4 surfaces. You hide. Now you can see the solid profile. If you want, you can hide this plane and curves. You have to go to edit, search in the type. If you want, you can drop down, you can search and find. Otherwise you can use this from element. Which element I have to find means this plane. So I am choosing this plane as an element. So now see, in the type automatically it is taking plane. Then search all the planes available. So these are all the planes available. Then select all the planes. Now see, all the planes are selected. Then we can hide. Same way, those profile also we can hide from element. Curve, you see curve is selected. Then search, all the curves are selected. Then select all the curves, everything is in green, red, orange color. Now you can hide. Like that, using this search option, you can hide all the visible curves and planes. Now this is the final propeller blade profile. And there is one small groove in this portion. So there is one small groove which is at 25 mm from the root section, and the dia will be around 40 because 5 totally 40. And I will take plane from this end, it will be very easy to offset. So I am offsetting another one plane at 25 mm. On that plane I am going to draw the circle of dia 40 mm. Then I can remove the material for 5 mm gap. So I have to do the reverse side. So material is removed. Okay, so this is the one side blade, maybe left side blade. Then the next part, we can take this barrel. So here is the geometry. So that barrel, if you see in the center, it has the axis symmetric cup-like structure. Then there is a longitudinal tube-like structure. Then there are holes and some removed out parts. So we will start from this center hub-like structure. So here they are given the dimensions. So the outer profile first you have to take 50 mm, 5 mm, 44, 105, etc. So now we will design that. So I am using profile tool. So in the bottom it is around 55. So roughly first I have drawn the diagram, then I can give the dimensions. So this is 55, this is 5, and this is 40, and angle between these two is 105. Distance between these two is 44. That's it, we have created the profile. And there are two corners of 5 mm. So here 5 mm and here 5 mm. the final profile is ready. Then we have to rotate this about the center axis. Z axis are about the line. So first we have the axis symmetric cup-like structure. Then we can go for the longitudinal tube-like structure. So here the dimension is given, the inside one. So 44 mm, outer dia is 29. The total length is 150 mm. So that we will get this longitudinal tube-like structure. So any plane you can take. Again I'm going to use this profile tool. So now I can give all the dimensions. So this is 44. And this is 5. And this is 29. And that's it. I can remove the extra lines. Then we can have a mirror of the same profile on the other side. So for the mirror, first select the profile. About this axis I am going to mirror. So this should be unselected. Now mirror. Now I got the profile. So this I have to extend to 150 mm. So if you give mirror extend, it will be just 75 mm on both sides. So this profile also ready. Then like I mentioned, this fillet edge radius 5 on these places, and from the top view here this fillet edge radius is 15. Both you can give now itself. So this line and this line 5 mm. Then these 4 corners 15 mm. That's it. All those fillets are given. Then we have to remove the material here so that the shaft will be, the propeller blade hub portion will be fitted within this. And you can take the same plane. You know the dimensions. If you want, you can check it. It is of 25 mm, because we know the propeller blade hub section circle is of dia 50 mm. So for the 50 mm we have to make a hole here, that is 25 mm dia radius. Simply you can take the circle of dia 40 or radius 25, then remove the material on both sides. That's it. So most of the work is done. Then there are some holes to attach it, and there will be 2 stoppers, okay, which will stop the blade to come out. That stop those dimensions. So you know that length is totally 25 from the edge. The cut we made in the blade is 25 mm. So I can offset the blade plane at 50 mm on both sides, and even one side is sufficient. So here I am going to make that stopper so that that cut made in the propeller blade will be fitted within this properly. So that they are given. this is 20 mm for that. So same way opposite side we have to create. Instead of creating, again we can use the rectangular pattern. So to object, or simply the symmetry we can give, it will be very easy. So this object, this pad about this thing you can create. So that's it. Now we can make the holes of required diameter. So the center hole dia is 12.5 radius. Around that we have 4 holes, each hole radius is 2.5, and I have mentioned the dimensions here. So it is at 15 mm away from the center, 4 holes. From here to here it is 50. Here to here also 15. So one hole we made it. Then using the circular pattern we can make the remaining circles, that is using rotate option. So this is the object. I have to create 4 more about the center point, and angle will be so 90 degree. Okay, already main is there, so remaining 3 profile. So these 4 hole also created. Then outside, parallel to this, we have 2 circles. The dimension is 48.5 from the center here. This is 15 only. So one side we can create, another side we can do the mirror. So first we will make this circle 48.5 and 15. All are having same radius. So this is 15. And this is 48.5. Then this circle 37.5, and from this edge it is 15. So here one circle, from here to here it is, from the center to this surface it is 15. Circle dia is 5, that is radius is 2.5. Then this vertical height they have mentioned 37.5. So one side I have created, remaining simply we can do the mirror image. So we can select these two profiles, then mirror image about this axis, then we can select these four, then mirror image about this vertical axis. So all the circles are created now. Now we can make a hole. That's it. This is the final barrel design. So next we have dome structure. So this is the front view. This is the top view. Like that you can take it. So in the front, and just like a spline. So they mentioned the dimensions. So the dimensions are height. So the outside radius is 89. Maybe we'll start with this inside one. Then you can give offset of 2 mm outside. So 87.5 the inner radius, and the height will be 180. So it will be 87.5. And this is 90. This is 70. It is not mentioned there. This is 182, 180 inside. So this is the first profile. Then you can offset the profile, or you can create another one profile for 2 mm. The creating will be easy, I think. Just create one spline. First you join these two. Now this is a closed profile. So I have mentioned distance between these two is just 2 mm. So here 2 mm, here 2 mm, here also 2 mm. And this height also will be 90. That's it. This profile is created. Now we can revolve around the center axis, about the Z axis. So the dome is created. Then there is an opening for the blade. So the dimensions are 50 as a height, and radius is 27. So to choose here. And the distance between these also equal to the radius. So profile is fixed. We can simply do the mirror on another side. Now we can remove the material for this portion. So dome is created, then there are circular holes. So there will be 3 holes. It is not clear properly here. The same 3 holes, 30 degree is the angle between the holes. Hole dia is 2.5, so that you have to make it. So the opposite side, first I am making 1 hole. So radius is 2.5, and from the bottom it is 4 mm. So this first you can make it on both sides. So I have to create the another 2 circle on both sides, 30 degree, 30 degree. So at a time you can create, always individually you can create it on both sides. So current solid is the pocket. Then I need one more with 30 degree angle for the Z axis. Similarly, another circular pattern you can try. So solid is pocket, reference is Z, and give minus angle now. So now this is the final dome design. Then at last we have the circular plate. This is the plate structure. So two radius is given, 4 holes, 15 with the 2.5 is given in the center, and the side holes also given, and this height has to be mentioned. This is 87.5. We will take 89.5 outer circle. We will take it. The thickness mm. Then to reduce the 2 mm, we can make a pocket, or we can use this shell too. Here in the center, 4 holes. rotate anything you want. Then remove the material. Then 3 circular holes to match with the dome size to attach with the dome. 2.5. From the bottom it is 4. So this side has to be attached. So these 3 holes should be aligned parallelly with that, and these 4 holes will be aligned with the barrel holes. And it should be 6, so that from here to here it will be 4 opposite side. Here also first you can make a hole. So now vertical axis is x. About the x-axis 30 degree you have to rotate. So this way you can see x is vertical. Same way solid is the bracket, axis is the x. Now angle is minus, so that it will be in opposite side. So this is also greater.